Today I'm going to talk about linkage, linkage equilibrium, and linkage disequilibrium. Linkage means when two genes are located on same chromosome. As this picture, gene A will located at locus A can have allele big A or little a. Gene B will located at locus B can have allele big B or little b. We assume during meiosis, different chromosomes would pass from parents to offspring independently. Therefore, for two genes located at different chromosomes, we may also assume that their alleles would independently pass to offspring. We know crossing over will happen during meiosis. Potential is a genotype before crossing over, and recombination is the new combination of a genotype after crossing over. Allele are independently passed to offspring, then the ratio of potential to recombination will be 1 to 1, but in reality, potential always more than recombination. If we run parent 1 have genotype big A little a, big B little b, with another parent which has genotype little a little a, little b, and if the ratio of offspring is 1 to 1 to 1 to 1, we see that it's no linkage. If the ratio of is not 1 to 1 to 1 to 1, for example, it's 2 to 0, 2 to 0, then we say the linkage is present. And sometimes the ratio of phenotype of offspring is not 1 to 1 to 1 to 1, but really close to it. Then that is really hard to tell there is a linkage or no linkage. We use chi-square to analyze either there is no linkage or linkage is present. For example, we cross parent have genotype big A little a, big B little b, with another parent have genotype little a little a, little b, and we get 1,000 individual offspring. Expectation, we should have 250 individuals for each phenotype, but in fact we didn't get this number. The two big number would be potential and two number would be recombination. The total of expectation, potential, and recombination would be 500, and the total potential observation number is 680, and total recombination observation number would be 320. We could use the equation to calculate the chi-square. Two genes are linked. There is also two situations, linkage equilibrium and linkage disequilibrium. Linkage equilibrium means when the genes at two loci are independent of each other. And linkage disequilibrium means when two genes at two loci are not independent of each other. That is frequency of big B allele, that is of little b, frequency of big A, that frequency of little a. You can see from this picture, allele little a have same frequency to link with allele big B and allele little b. That is linkage equilibrium. And in the picture we can see allele little a is more likely to link with allele big B than allele little b. That is linkage disequilibrium. And we know natural selection, genetic drift, mutation, and migration will cause linkage disequilibrium. Natural reproduction will break linkage disequilibrium.